Hey guys, in today's video we'll be discussing Unit 2.4 of the Math AAHL course, and that is the key features of a graph. In this section, the features which are covered are turning points, asymptotes, and intersections. So first we'll begin with turning points. And what are turning points? So let's say we got this graph here, right? It's a nice little graph. What are the turning points of this graph? A turning point is an area where the sign of the gradient changes. So sign of gradient changes. And what does that mean? Well, a positive gradient, so let's say plus m, where m is the gradient, is when the graph is increasing. So when it's going from down to up, when it's increasing, right? And a negative gradient, so negative m, is when the graph is decreasing. So it's going from up to down, up to down. And a turning point is essentially any area where the graph either goes from positive to negative or negative to positive. So here the graph is increasing and starts decreasing. So this is a turning point. Decreasing and starts increasing. So this is also a turning point. So here, 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 and here. These are all turning points. And how do we label these turning points? Well, to start off, there's two types. We've got maximas and minimas. Let's color coordinate this. And minimas. And what does that mean? A maxima is when the gradient is first increasing and then starts decreasing. And a minima is the opposite. So the gradient is decreasing and then starts increasing. So here, gradient is increasing and then starts decreasing. So this is a maxima. Here, the gradient is decreasing and then starts increasing. So this is a minima. And then here we got a maxima, another minima, and a maxima. And then there's two types of maximas and minimas. There is a local and there is a global. And what does that mean? Well, a local minima or a local maxima is a maxima which is the turning point or the highest point or lowest point in its specific region. So this is the highest point in this area. This is the lowest point in this area. While a global maximum is the maximum point of the whole graph, and the global minimum is the minimum point of the whole graph. So this would be a global minimum. This is a global max. And then these are all local minimum, and these two would be local maximums. And these are essentially your turning points. For now, you just need to be able to identify the turning points. You don't need to find their exact location. To find the exact coordinates of a turning point, you would need calculus. You need to find the differential of the equation and set that to 0, and you'll get the coordinates of the turning point, but you don't need to know that for now. Okay, your second key feature of a graph are asymptotes. And asymptotes are essentially invisible lines which your graph will come very, very, very close to touching, but it will never actually touch it. And what does that mean? Well, first we'll specify that there's two types of asymptotes. There's a horizontal, which is your y asymptote, okay, and there's a vertical, or your x asymptote. And what do these mean exactly? We'll start with the horizontal asymptote, or your y asymptote, meaning an asymptote that cuts across your y-axis. Okay, so if this is your y-axis here, your y asymptote will cut across the y-axis. And again, what this means is that you have this graph here. Your graph won't touch this y asymptote, but it will get very, very, very close to touching it. Okay, and how do you express this? Well, again, your line won't touch it, it'll just get close to touching it all the way to infinity. So as how you can express this is as x approaches infinity, so as x goes all the way to infinity here, your y, or your f of x, approaches k, where k is just the value of the asymptote. So if the asymptote was at y equals 2, your k value would be 2. And this means that as x approaches infinity, f of x gets very, very, very close to 2, but doesn't actually touch 2. Okay, and the same concept applies for your vertical asymptotes. So if you have a line that cuts across your graph like this, let's say you have this graph, and then you get close to this x asymptote, but you never actually touch it. You get very close, but as y goes to infinity, as y goes all the way up, you never actually touch this line here. Your x never becomes this value here. And how do you express this? Well, as your f of x approaches infinity, so as your graph goes all the way up, your x approaches h. So your x gets very, very, very close to this value of x, but it never actually touches it. And let's have a quick example to show what exactly this means. So let's say you have the function f of x equals 3 over x plus 1 minus 2. Okay, how do you calculate the asymptotes here? Well, let's start with the y asymptote. So again, we said with the y asymptote is as x becomes a really big number, f of x becomes some kind of value. So here we want x to be a really big number, right? So let's say f of x, or the function of 1,000, and this would be 3 over 1001 minus 2. And 3 over 1001 will just be a very, very, very small number. So let's say it's like 0.0001 or something minus 2. And therefore, your y asymptote, or your function of 1000, is going to be like negative 1.9998. Right? Or, sorry, 1.999. So as x becomes a really big number, your y value becomes very close to 2, right? Very close to minus 2, but it never becomes minus 2. So you'll have a y asymptote, or a y asymptote at y equals minus 2, right? Or basically, y cannot be minus 2. Y gets very close to minus 2, but it'll never actually be minus 2. And next you have your x asymptote. And this one's a lot easier to do. So again, this is as f of x approaches infinity, x equals a number. But an easier way of doing this is, for this function here, you have a fraction, right? But you know with fractions that the denominator, the bottom number, can never be 0, okay? So you know that this x plus 1 here can never be 0. So then you just solve for x. X cannot be minus 1. And that's literally it. You have here, x cannot be minus 1. And then we move to our final key feature of a graph, which are intersections. And your intersections are basically the points where your graph touches either the y-axis or the x-axis, where the y-intercept is where your graph touches the y-axis, and the x-intercept are the places where your graph touches the x-axis. Pretty self-explanatory. So we'll use the same function to demonstrate this. So first we'll start with our y-intercepts, right? And y-intercept is, again, when the graph touches this y-axis here, right? So it's here at the y-axis, x equals 0, right? So to find the y-intercept, all you have to do is find the function of 0, or what is the x-coordinate, or what is the y-coordinate when x equals 0. So this would be 3 over 0 plus 1 minus 2, which equals 3 minus 2, which equals 1. So at y equals 1 and x equals 0 is your first coordinate, 0, 1, right? And then you have your x-intercept. And this is pretty similar, where now you want where the graph touches this line here, right? And this line is when y equals 0. So your x-intercept is when your function, so 3 over x plus 1 minus 2 equals to 0. And then you just solve for that. So 3 over x plus 1 equals 2. 3 equals 2x plus 2. 1 equals 2x. X equals a half. So at x equals a half, y equals 0, you have your second intercept. And now that you have your intercepts, you have your asymptotes, you can start to sketch your function. It'll look something, again, never touches this line, touches the two intercepts, never touches this line. And for this type of functions, you'll also have something that goes like this on the other side. And yeah, that's how you graph a function. So in IB style questions, whenever you're asked to graph a function, you'll always be expected to show any turning points, asymptotes, and intersections that the function may have. So here there's no turning points really, but you do have the asymptotes and you do have your two intercepts, and you will be expected to always show those on your IB style questions. Okay, to finish this video off, we'll do a quick IB past paper question asking us to sketch the graph. So here we have f of x equals 1 minus 3x over x minus 2. First, let's start with the asymptotes, right? So your x asymptote is what, as we said before, when you have a fraction, the bottom cannot be 0, right? So let's do x minus 2 cannot be 0, x cannot be 2. So we draw a quick little asymptote, at x equals 2. Next, you have your y asymptote. And for this, again, if we make x a really, really, really big number, you will just have 1 minus 3000 over 3000 or 1 minus 3000 over 1000 minus 2, which is not exactly, but almost equal to minus 3, right? So again, you'll have your y asymptote at minus 3. The graph will get very close to minus 3, but it'll never actually touch the minus 3 line. And these are your asymptotes. Next, you have your intercepts. So your x-intercept is, again, when y equals 0. So 1 minus 3x over x minus 2 equals 0. 1 minus 3x equals 0, because you just multiply both sides. Minus 3x equals minus 1. X equals 1 over 3. So here you're going to have when y equals 0, x equals 1 over 3. That's over here. And your y-intercept is when function of 0. So it's 1 minus 3 times 0 over 0 minus 2, which equals minus a half. So minus a half. And then you just sketch the graph to match these descriptions. So again, never touches the asymptotes, but passes through the intercepts, and the same thing on the other side. And yeah, it's really as simple as that. Again, there's no turning points here, but you are expected to show the asymptotes. Let's actually specify those, because you need to specify. So x cannot be 2, y cannot be minus 3. And you also need to specify your intercepts. So this is at x equals 1 over 3, y equals 0, and this is at x equals 0, y equals minus a half. And yeah,